This video is going to work through the right triangle trig word problem worksheet. So if you haven't done it yet, you could download it from my Canvas page, and I'm going to do this as you watch the video, so you could attempt the first problem and then watch the video just to make sure you've done it right, and then attempt the second problem. Or you could watch the first couple and then go back and try to do it, but anyway, you could use this video in conjunction with trying to work through the worksheet. So here we go. The angle of depression from the top of the Seatown lighthouse 90 feet above the surface of the water to a buoy is 15 degrees. How far is the buoy from the lighthouse? Okay, so first thing I always do is draw a picture. Here's my Seatown lighthouse, I guess, and the top of the Seatown lighthouse is 90 feet above the surface of the water. So maybe it's on a cliff, I don't know, but the surface of the water is down here. What they're telling us is this total distance from here to here is 90 feet. And the surface of it says the angle of depression. So this is a vocabulary word. If you draw a line of sight from the top of the lighthouse down to the buoy, this is my buoy, isn't it cute? This line here is called the line of sight. There's something called an angle of depression and an angle of elevation. So the angle of depression is from the perspective of the top thing that's looking down. The angle of elevation is from the perspective of the bottom or the lower thing looking up. And the angle of depression and angle of elevation is always between the line of sight and a horizontal line. So the angle of depression is this angle right here. We'll call it AOD. So we have a 200-foot tower. So again, we know, let's see, what is the angle of elevation? That's what it's doing. So the angle of elevation would be this guy right here. So as I'm looking up from the tip of the shadow, that's the angle of elevation between the horizontal line and the line of sight. So we'll call that theta, and we know the opposite side and the adjacent side, so that again makes me think of tangent. So tangent of theta is equal to opposite over adjacent. So again, we're looking for an angle, so we undo this by taking inverse tangent, which is second tangent on your calculator. So that would be theta is equal to inverse tangent of 2 over 8, because I can just reduce that, right? Because it's just about the ratio, not the actual numbers. So the inverse tangent of 2 divided by 8 is approximately, whoops, I think I did that in radians. Just a minute. There we go. Inverse tangent of, oh, it's in radians again, degrees. Inverse tangent of 2 divided by 8 equals inverse. Sorry guys, my calculator's not working. Inverse tangent of 2 divided by 8 equals 14 degrees. Okay. This is the same problem as before, so I'm not going to redo that. Oh, actually, this is what is a different look at the same problem. So I still have that same 100-foot conveyor belt, so that's still 100 feet. And we're going to have a triangle. Here's the window to the farm, to the barn. The conveyor is tilted at an angle of 30 degrees. So angle of elevation, so that means that's 30 degrees. So the question is, to what height can the hay be moved? So how high up can I get? So we're trying to find this over here. So I want to know the opposite, and I have the hypotenuse. That makes me think of sine. So I'm going to go sine of 30 degrees is equal to the opposite over hypotenuse, which means 100 times sine of 30 is equal to h. And actually, we know what sine of 30 is, don't we? That's a friendly angle. Sine of 30 would be 1/2, so that means 50 is equal to h. So we can get those hay bales up to 50%. Jack is on one side of a 200-foot wide canyon, and Jill's on the other side. So we got this big canyon. There's Jack, and there's Jill. Their trail guide is down this canyon exactly halfway between them, right there. And this distance is the same as that distance. Jack and Jill can both see the trail guide at an angle of depression of 60 degrees. Aha! So he's looking at her at the trail guide. She's looking at the trail guide. Their angle of depression is 60 degrees, which means both of these are 60 degrees. How far are they from the trail guide? Well, how far are they from the trail guide would be this hypotenuse right here. So, and we could do either one. So what I'm going to do is just to grab one of them and draw that little line there. And since it's a 200-foot wide canyon, we know that this distance right here is 100. So it looks like we have the adjacent side and we want the hypotenuse. So think of cosine, so that'd be cosine of 60 degrees is equal to adjacent over hypotenuse, and we'll call this d for distance. So that means that distance is equal to 100 divided by cosine of 60. So I can multiply both sides by d and then divide both sides by cosine of 60. So then I get 100 divided by cosine of 60. And I get d is equal to 200. Hey, wait a minute. This is an equilateral triangle, isn't it? I could have done that without trig. Look it. If that's 60, 60, that would have to be 60 also. And since this is 200 feet across, that means each one of these would have to be 200 feet. I wish I would have seen that earlier. Okay, a damsel is in distress and is being held captive in a tower. There's the tower. Her knight in shining armor is on the ground below with a ladder. When the knight stand, I guess that should be stands, 15 feet from the base, so that'd be out here 15 feet of the tower, and looks up at his precious damsel, the angle of elevation to her window is 50 degrees. So that would be 50 degrees. How long does the ladder have to be? Okay, so we have adjacent, and we want to know hypotenuse, don't we? Because that's where the ladder would sit. So adjacent hypotenuse, that makes you think of cosine. So cosine of 50 degrees would be equal to adjacent over hypotenuse, which means h is equal to 15 over cosine of 50 degrees. I'll throw that in my calculator. 15 divided by cosine of 50. And I get h is approximately equal to 23.3. So he needs a 24-foot ladder. Okay, a 12-meter flagpole casts a 9-meter shadow. 12 flagpole, 9-meter shadow. Find the angle elevation of the sun. Angle elevation, that should have said to the sun. Oops. So we're looking down here. We want to know what this angle is. So we know the opposite and know the adjacent. So that would be tangent of theta is equal to opposite over adjacent. So I need to take inverse tangent. Let's see, that would be 4/3 because we can reduce it. So let's go inverse. Let's go inverse tangent of 4 divided by 3. Looks like theta is approximately 53.1 degrees. Suppose you're flying a kite and it gets caught at the top of the tree. What does a kite look like? Okay. You've let out all 100 feet of the string for the kite, and the angle that the string makes with the ground is 75 degrees. So we got this thing going out like that, Here's the ground, so that is 75 degrees is what it's saying. Instead of worrying about how to get your kite back, you wonder how tall is that tree. Of course, that'd be the obvious thing to do. So we know this is 100 feet because that's how long the string is. That's my hypotenuse. So I know the hypotenuse, and I want to know the opposite because that would be the height of the tree. We'll put an H there for height. Opposite and hypotenuse are sine. So I'm going to do sine of 75 degrees is equal to opposite H over hypotenuse 100, which means 100 sine of 75 degrees is equal to H. So I would do sine of 75 degrees times 100, so that would be 96.6. 96.6 is approximately equal to H. Approximately equal to. That's a tall tree, doggone it. Oh, and that's the whole thing. All right, so as I said, I think it's a good idea to work the, well, I guess it doesn't do any good to tell you now because you've already watched the whole thing. But hopefully this is helpful. Let me know if you have any questions.